Now, yesterday we talked about how the graph moves from left to the right. The little bug going uphill, little bug going downhill, little bug flat, that increase and decreasing constant. Today we're going to talk about extrema. And before we talk about absolute max and min, I want to talk about the word extrema. Extrema, as I was thinking it, derives from the word extreme. They are extreme values. But extrema are any hilltop or valley in the graph. Now that's more in not mathematical words, but in just a way for you to identify them. Any hilltop or valley in the graph are called extrema. So if we look at the graph that has been provided, I'm just going to put a little dot on all the hilltops and the valleys. Each one of those points are considered extrema. But it's a matter of what kind of extrema they are, okay? So as long as it's a hilltop or a valley in the graph, it's considered an extreme value, an extrema. Now, here's the way that we have to think about it. A relative maximum is any hilltop. An absolute maximum is the highest point of the graph. So the highest hilltop of the graph, or the highest point of the graph. Okay, so a relative max is any hilltop. An absolute max is the highest point of the graph. Now, if we take a look at the graphs that we see here, here's a hilltop. This is a relative max. And I'll just put it RELMAX, the quickest way to do it. This is a hilltop. It's a relative max. It is not the absolute max of this graph. The absolute max of this graph is infinity. So it has no absolute maximum for a hilltop. So what kind of graph has an absolute maximum? Well, that one right there is an absolute maximum. It is the highest point. It's a hilltop. Think of it as the Mount Everest of the graph. It's the highest. Mount Everest is the highest, what is a K2 or whatever, is the highest mountain on the planet. It is the highest mountain of the graph. So an absolute max, some graphs don't have an absolute max. They have hilltops. This one here is a relative max. It's a hilltop. It's not the highest. It's not the Mount Everest. It's just a little hilltop. So all hilltops are relative maxes. Some of them are absolute max if they're the highest point of the graph of all, okay? Does that kind of make sense, the difference in the language? Okay, it's just a language thing. Now, if we look at relative minimum, it's the same idea. A relative minimum, I'm just going to put relative min, is any valley. So an absolute min is the lowest point of the graph. Okay. So a relative min is any valley in the graph. So like if we look at that first graph, this is a relative min. This is a relative min. If we look at this graph, let's look at the extrema that are there. These are relative mins. The valleys, relative mins. There is one relative max, a peak, a hilltop. But this one is special because it is an absolute minimum as well. It is the lowest point ever. If you've ever heard in the ocean, there's Mariana's Trench. That's the lowest point in the ocean. This is the lowest point of the graph, is an absolute minimum. That is the absolute smallest height that my graph will ever go to. So when we're talking about mins and maxes, we're talking about the height relative to the things around it. So hilltops are maxes. Valleys are minimums. Okay? So now we just have 2 examples to look at, okay? And this is what, how I want you to do them. Just a minute, let me write down the function so we can look at it. So it says, the instructions say, to classify the types of extrema for the functions using Desmos. So at this time, if you want to open up a tab in Chrome to Desmos for the graphing calculator, to follow along and practice with me so that you can do it, okay? So our first function was 2x to the 6th plus 2x to the 4th minus 9x squared. Okay. So for me, okay, I'm going to take a screenshot where I've tapped, and for you, you would click the low points and high points, the hilltops and the valleys. I'm going to make a little, now for you on your paper, all you got to do is make a little sketch of the graph. It doesn't have to be pretty, just noting what those points were on your graph. So you can make the XY axis, and then I'm going to put this into Desmos. Okay. And then we're going to just label the points. This is a hilltop. It definitely, all hilltops are relative maxes. Is it the absolute highest point of the graph? Can we go higher somewhere, anywhere else? Those arms are going up, right? So can we get higher on those arms? Yeah. So it's just a relative max because we can find other places that are higher. It's not the absolute max. Does that make sense? If those arms were pointing downward, then we'd be okay. Okay. These points here are relative minimums because they're a valley. They're a low point of the graph. Are they the lowest point that we can ever be at? Yeah. So they are also absolute minimums. That's all I expect to see. There's no real math. It's just identifying what those points are. So you just sketch it on your paper, label what the points are, because Desmos gave you what the points are, label, and then tell me what they are. That's all. That's it. That's the assignment, okay? Let's do, everybody good with that first one? Okay, let's do one more. If you look, this is a hilltop. It's a relative maximum. Can we go higher somewhere in the graph? Yeah, so it's not an absolute max. This one is a relative minimum. It's a valley. Is there somewhere we can go lower on the graph? Yes, so it's not an absolute minimum. So that is your assignment. That's the notes. You're going to sketch it in Desmos and then label and classify all of the extrema. That's it. So you're doing 5 problems. Pull up Desmos, draw what you see, label the points, bam, that's your assignment. That's it, okay?